Hello students. After the characteristics of matter, we have our next topic is states of matter. Now there are mainly three states of matter: solid, liquid and gas. There are two other states of matter also. Fourth one is plasma and fifth is Bose-Einstein condensate. Now first we'll discuss solid, liquid and gas. Look at this diagram. You have to draw this diagram in your notebook also. This is the diagram of solid state, liquid state and gaseous state. See how the particles are arranged in all the three. In solid they are very closely arranged. In liquid there are some spaces, but in gases they are very far away. Lots of spaces present between the particles. Now first we will start with packing, how the particles are arranged in all the three states. First one is packing. In solids, constituent particles are very closely packed. There are no intermolecular spaces, they are very closely packed. In liquids, the constituent particles are less closely packed. In gases, the constituent particles are free to move about. Our next point is interparticular distance. That means the space is present between the particles. In solid, what we have, look at this diagram. In case of solids, the distances are very smallest. In liquids, the distances are larger than those in solids but smaller than those in gases. But in case of gas, the interparticle distances are the largest. The particles are very far away from each other. The next point is forces of attraction. In case of solids, the forces of attraction, they are strongest. But in case of liquids, they are weaker than solids but smaller than those in gases. But in case of gases, the forces of attraction are the weakest. Next is the shape and volume. In solids, they have a definite shape as well as definite volume. But in case of liquids, they have definite volume but no definite shape. They take the shape of the container in which they are kept, either in a bottle or in a glass or in a jar. They do not have a definite shape but definite volume. The volume will not change. Either we put the same liquid in glass, bottle or jar. So they have a definite volume. In gas, neither have a definite shape nor a definite volume. Next is compressibility. Compressibility. What is compressibility? It is the tendency to decrease volume when some outside force is applied. In case of solids, they are completely incompressible. We cannot compress the solids. In liquids, almost incompressible, a little bit compressible. But gases, they are highly compressible. We can compress the gases. Next is rigidity or fluidity. Rigidity is the tendency to maintain shape when some outside force is applied, and fluidity means the tendency to flow. The solids possess rigidity. They are not very rigid. The particles are strongly attracted and have no space, so they don't have the tendency to flow. They do not show fluidity. But liquids can flow easily, so they possess fluidity but lower than that of gases. Gases flow more easily and have highest fluidity. The next is energy. In case of solids, the particles have minimum energy because they are very strongly attracted to each other, have the minimum spaces present between the particles. So the energy will be minimum. They cannot move. But in case of liquids, the particles have energy higher than those of solids. The particles are loosely as compared to solids. They are loosely bound. So they can easily move. So they will possess higher kinetic energy that of solids. But in case of gases, they flow more. The particles have highest energy because they can move very faster as the spaces present between the particles is very large. The next is density. What is density? Mass per unit volume is known as the density. Solids have the highest density. In liquids, their density is lower than those of solids but higher than that of gases. But in case of gases, they generally have low densities because the mass is present in a very large volume. The particles occupy large spaces. They have very large intermolecular spaces present between the particles. Now next is diffusion. What is diffusion? The intermixing of particles on their own is known as diffusion. In case of solids, normally do not possess the property of diffusion because they are strongly attracted to each other. But in case of liquids, they show diffusion. Solid, liquid and gases all can diffuse into liquids. But in gases, they diffuse very rapidly. The rate of diffusion is inversely proportional to the square root of its density. Lighter gases diffuse more rapidly than the heavier gases. Now, after discussing all the properties of solids, liquids and gases, we will discuss the activities given in your book one by one. The solid state. You will collect the articles like pen, book, needle or a piece of wooden stick. What you will see, do all these have a definite shape, distinct boundaries and a fixed volume? Yes, if you draw with a pencil, you will see that they all have a shape, boundaries and a fixed volume. Yes. What happens if they are hammered, pulled or dropped? They will not break as they are solids. Are these capable of diffusing into each other? No, solids do not diffuse. Just now we have discussed. Try compressing them by applying forces. Are you able to compress them? No, we cannot compress the solids. We cannot compress them. Solids, they have a tendency to maintain their shape when subjected to outside force. So they may break under force, but it is difficult to change their shape, so they are rigid. This we have already discussed. Now we'll discuss the following examples. What about a rubber band? Can it change its shapes on stretching? Is it a solid? Yes. Is it a solid? A rubber band changes shape under force and regains the same shape when the force is removed. If excessive force is removed, it breaks. Rubber band is also a solid. Next is what about sugar and salt? When kept in different jars, these take the shape of the jar. Are they solid? Yes, they are solids. But the shape of salt and sugar crystals will remain fixed whether we take it in our hands or keep them in a different jars. Next is what about a sponge? Is it a solid? Yes, this is also a solid, yet we are able to compress it. Why? Because a sponge has minute holes in which air is trapped. When we press, the air is expelled out and we are able to compress it. Although a sponge is solid, but why we are able to compress it? Because it has a hole, space is present in which air is trapped. Because of the holes, the air is trapped, we are able to press it easily. So we can compress it in spite of being solid. Sponge can be compressed. Other solids do not show this type of property, but sponge has holes due to which it can be compressed. Now the activity of liquid state. What we will take: water, cooking oil, milk, juice, a cold drink. Containers of different shapes. Put 50 ml mark on these containers using a measuring cylinder from the laboratory. Now what we'll see. What will happen if these liquids are spilt on the floor? All these liquids will flow when spilt on the floor. Measure 50 ml of any one liquid and transfer it into another different containers one by one. Does the volume remain the same? Yes. volume of the liquid remains same. That will be 50 ml when it is transferred from one container to the other. Does the shape of the liquid remain the same? No. The shape of the liquid is not fixed. This we have discussed. Liquids take the shape of the container in which they are kept. So they will take the shape of the containers in which they are kept. They will not have a fixed shape. When you pour the liquid from one container into another, does it flow easily? Yes. When the liquid is poured from one container to the other, it flows. So, what we conclude from this activity, that liquids have a definite volume but do not have a definite shape. When they are poured from one container to the other, they can easily flow and take up the shape of the container in which they are kept. Now the activity of gaseous state. In this, we will take 300 ml syringes and close their nozzles by rubber cork. We'll remove the piston from the syringes, all the syringes, leave one syringe untouched. Fill water in the second and a pieces of chalk in the third. Insert the pistons back into all the three syringes. Now you can apply a Vaseline on the piston before inserting, so that for their smooth movement, we can move them easily. Now try to compress the contents by pushing the pistons in each syringe. What do you observe? In which case was the piston easily pushed in? The syringe which was left untouched, the first syringe, because it contained air, was the one in which the piston was easily pushed in. In the second, what we have taken water, was pushed in only a little. In the third, we have taken the chalk pieces. It will be very difficult. We could not push it at all. So the air is easily compressible, as this we have taken in the syringe 1, and water is almost incompressible, while chalk pieces are completely incompressible. Now, what do you infer from your observations? Now, what we conclude from our observations, that the spaces present between the particles of gases are the largest and intermediate in liquids and the shortest in solids. Therefore, gases are highly compressible, liquids are almost incompressible, and while solids are completely incompressible, we cannot compress the solid due to high speed of particles and large spaces between them. Gases show the property of diffusing very fast into other gases. This we have discussed in the differences between the solid, liquid and gas. The diffusion. Property of diffusion is very rapid in gases because the particles are very far away. They have very large intermolecular spaces, so they move very fast and diffuse rapidly. Draw this diagram neatly in your chemistry notebook and read the chapter.